All right, let's go ahead and kick this off. Welcome. My name is Ryan Lowe, and I am building a Alexa skill live over the next however long it takes me to go and build this. If you don't know who I work for Amazon Alexa. I am a evangelist. My role is to inspire and educate developers to go build cool stuff with Alexa. And so part of that is I need to build my own stuff. And so I'm doing that, and I'm going to do that live. And so I've been working on a skill last couple of streams, and it's going to continue for a while. It's a pretty big skill that involves Alexa and a bunch of other AWS services. So before I joined the Alexa team, I was on the AWS team as a specialist solutions architect. And so I know a lot more about AWS than I do Alexa. I've only been with Alexa for about 6 months, but it's a journey, and I'm learning, and it's a lot of fun. So what I'm actually working on is a skill specific to a use case that makes sense for me. And for those of you who don't know, I and a co-host, Jeff Blankenberg, host an office hours every Tuesday morning for Alexa, and specifically Alexa developers, to answer questions from the community. And we realized that we had just hours and hours and hours of archived footage in YouTube where we're answering questions about Alexa. And largely, this is kind of untapped knowledge, untapped answers, because it's nearly impossible to go find a specific moment in time where we're addressing a specific question. So the idea came to us, like, why don't we build an Alexa skill that allows users to go and search that archive footage for specific content? And that's exactly what I'm building. So I'm building a mechanism that's going to take archive photos from YouTube, pull it down into AWS, and then we're going to transcribe it and store those transcriptions into a database that we can search. And then eventually I'm going to get to building the actual skill, which hopefully we can get deployed here at the end of all this, where users can go and search and find content from the office hours. And so what we want to do is we want to end up building a full skill that can be completely deployable. I am putting this into GitHub at the end of every streaming session. I commit this to GitHub, so you can follow on my GitHub page. You'll be able to see it. It's one of the pinned repositories that I put there. And the end goal is that anyone could deploy this infrastructure. And so to that extent, I'm doing it in such a way that it can be easily deployed without having to go in and configure a bunch of services. So I'm using CloudFormation as infrastructure as a code to deploy a lot of this. And you get to watch me fumble around going and creating all these different services and stitching them together, and so on. So what have I accomplished so far? So what I've accomplished is not a whole lot. I've only been streaming for about 2 hours on this particular project. What I do have is I have this section here kind of stubbed out. So I have an S3 bucket that we've created, and then I've created the stub of a step function. So here I'm using step functions and state machines to orchestrate long-running processes. And then I have some Lambda functions that are kicking off and checking on the status of transcribe. So again, a pattern that I really like to do is long-running processes like transcribing videos can take a while. So I'll create a Lambda function to kick off the process, and then use state machines to kind of loop over and check on it with another Lambda function and check on the status of that. And that's about all I've gotten. And at the end of yesterday, we were, let me get rid of that. We were at the point where we kicked off the transcribe process, and it actually worked. So this is the state machine that we have created so far. It has transcribe start. So this is one Lambda function. It kicks off. It immediately goes into a wait where it's waiting for, I think, 30 seconds. It then checks on the status using another Lambda function. There's another Lambda function. And then it checks to see if it's finished or not. If it's finished, we end the state machine. If it's not finished, we go back to wait. And if it fails, then we go to this fail step. So I ran this at the end of it yesterday. You can see it took, what is that, about 15 minutes to run. yesterday, which is mostly just waiting on Transcribe to finish. And you can see here that the last Transcribe status, if I look at the output of that, you can see here that we have a nice Transcribe URL. So the job did finish. Also, we can go into Amazon Transcribe and see the job. This is the, I believe this is the job. Why do they both have the same? Let me refresh this page. That's weird. They both have the same name. There we go. So here's the job that started. And what I did is I did load into Amazon S3 a pre-configured MP4 video file that I downloaded from YouTube. I did have to convert the media content type, which is actually part of the state machine here. We're going to use media convert to automatically convert the YouTube version into a version that Transcribe can use. I'm skipping that part for right now and just went straight to Transcribe. So I took a pre-configured video, stuck it in S3, and used that. It's a video from office hours in September, and you can kind of see Amazon Transcribe gives you a transcription preview. So here is what comes out of Amazon Transcribe. It is just the raw text. And you can see here, Jeff is introducing himself, and then he introduces me, and we go about our day. And it's an hour-long office hour, so the transcription is quite long. What I haven't done yet also is I haven't introduced a custom vocabulary. So a custom vocabulary will help Transcribe get better at recognizing different words. And we will add that in, but we're going to add that in later and get to that. Okay, so the other part of this is that I am not creating this completely from scratch. I am borrowing a ton of this from this blog post that I found, which they've also open sourced into GitHub, where what they're doing, their approach is they're using the same exact process, but they're taking RSS feeds of podcasts and running them through this whole system. So our use case is a little bit different, but majority of their hard work I am leveraging and borrowing and maybe stealing to get to what we need to do. So you can see here that the state machine, where is the diagram? It must be down below. Their state machine here looks very similar to the state machine I'm creating, where they're downloading a podcast, they're starting Amazon Transcribe, checking on the status and doing the loop. The next step for them is to then process the text, and to do that, they're going to use Amazon Comprehend to kind of make sense of it. And so here they have a description of the different functions. Again, I pretty much borrowed these. Today I'm going to go and update these two functions to get them a little more consistent with my styles and what I want to do with it. But then I think we're going to get to these two Lambda functions here, where they're taking in the complete text of the transcribe process and then processing it, breaking it down into paragraphs. They break it down by speaker. We haven't gotten that far with it yet, but we'll see what happens. And again, this is the code that I've started. It's just two Lambda functions. I'm using the serverless application model framework to build and deploy all this, which kind of sits on top of CloudFormation. And so I'm able to write a CloudFormation template. So here is my template that I've created so far. I have an S3 bucket. I have an S3 bucket policy that restricts access to that bucket. And then I have my two functions, transcribe start, and these are the IAM policies that function needs. It needs to be able to call transcribe and load data from S3, and then transcribe status, which really just needs to check on the status of that. And then I have my state machine, which I have all the steps written in JSON syntax as a giant string. This gets a little cumbersome, and we're going to keep adding to the state machine. So this definition is going to get a little gnarly, but this is the way that works for me. There's probably a better way to do this. I saw that I'm using straight CloudFormation syntax here. I saw that Sam has a version of state machines in their syntax. I'm just going with what I know and how I know how to work it. So let's begin. So I think where I want to start is by updating the two functions I have. So like I said, I borrowed heavily from that repository, meaning I copy and pasted it over. I now want to modify this and get it a little bit more consistent with kind of my own coding styles. And there's a few things here that I just want to take. The first one is the logging. So if we go in to their functions and specifically in CloudWatch where the output is, there's not a whole lot of detail there. So I like to add a ton of detail into CloudWatch, control the log levels like they're doing with the environment variable. And we don't even have that environment variable set yet. But I actually like to define this a little bit differently. So I'm just going to delete their code. And what I'm going to do is I'm actually going to steal from myself. Let me actually put this on the main screen. So in my previous life, again, I worked for AWS. I built a number of solutions. So I was a pinpoint specialist, Amazon Pinpoint. So I specialized in being able to send email messages and SMS messages, and I worked with Pinpoint and SES. And so I built this solution which takes the events that come out of that and create a database so you can go and query and look at engagement history and all that. But like any good developer, I like to just steal from myself. So this code that I wrote, in order to produce a solution, has to be code reviewed, has to be go through security audits, and it's a pretty tough process. So I like to just steal from the hard work I did in the past, especially doing things like logging and so on. So here I deleted that logging. What I'm going to do is come down to the beginning of my Lambda handler and put in my logging statement that I just copied over from this repository. So here I'm checking the log level from the environment variable log level, which I haven't set yet. And if it's in one of these, then it uses that. Otherwise, it uses the debug. For now, I want the default to be info. And then it sets the logging level. And then what it does is it immediately logs the event. So the incoming event gets logged, which is something that we weren't logging before. Okay, so now I need to make sure that we are setting a log level environment variable. So I can go back to my template here, and I can actually add that as a property when it's creating the function. So this is the function I'm working with. So here I'm defining the code URI, which tells Sam which folder to go and compile and build your zip file from. The handler, which is the starting point of that function, the runtime. But I can also, and let me just double check the documentation. So here is the SAM documentation, specifically the syntax. And these are all the different properties that we can set. And specifically what I want is the environment and then variables. So I can add environment and then what is it, variables. If I could type, that'd be great. And then log level. And what I'm going to do is I'm going to specify info here. So when it's creating this function, it will create an environment variable named log level and specify the value as info. And maybe as we progress and get more confident with the code, I can change this to error by default. But for right now, I do need level info because I make a lot of programming mistakes that are caught when I run it because I'm a terrible programmer. Okay, so let's jump in here. Okay, so now let's go back to our function. So I've established the environmental variable. Great. I need to make sure that all of the logging is in the same format. So we want logging dot. They initialized a logger. That's just not my preferred way of doing it. So here we have, actually I should probably do a search for logger just so I have, and so here I'm just going to do this exact same thing. Logging. Okay, so now I've replaced all of their logger statements with my logging statement. Again, it's just my preference. And then the last thing I like to do, so I minimally logged the incoming event, I also like to log the outgoing return value. And when you're doing step functions, it's really important to understand how the events, what's getting passed into a function, what gets passed out, because what you pass out of a function can get passed into other functions down the chain. And that's exactly what we talked about that yesterday, but that's exactly what I'm doing here. So what I like to do is do something like this. So let's change this from a giant return statement. Let's return retval, but let's define like this. Okay, so now I'm defining the return value. I'm logging it, and then we are returning it. It's just a few lines of code to give me a little bit better understanding. The other thing I like to do is I like to log the response to any API. It's super helpful. Again, these are all info, so I can turn this down later so that we're not getting that much information. So these are debug. This to me is an info level. There's probably a much better way to handle all of this, but this is how my preference of doing it. Okay, so now this function's looking good. Where is this being used at? Okay. Sure, I'll leave that in there. Again, I copy and pasted a lot of this code over. I really need to go back and clean up, and I'm starting to do that now. Okay, so let's do this to our next function, which is the function that checks on the status. So the very beginning thing inside the handler is understand the logging, and then log the incoming event. I don't even have logging here, so let's add that as an import. And then let's do the same thing and add the environmental variable with the value of info. Okay, so now we're logging an incoming event, and we want to do the exact same thing and log the outgoing event. Here we already have a retval. And there we go. Okay. We should also, the API response, let's also just log that. Info response. Since these methods, these functions are really so short, I don't need to add like a really descriptive understanding of, you know, what I'm logging here. I'm only logging the payload, the response payload. I could add more informational text around it, but since this is kind of like a single-use function, it's pretty obvious to me what's going on. Okay, the other thing is I like to create my clients at the top of the function. So there's my transcribe client. Is it happening anywhere else? Definitely here. Actually, no, this is grabbing the session, so never mind. That's fine. Okay. Now those two functions have been updated, which is great. Now we can go ahead and move on to like creating another function. But first, I always like to deploy. Actually, I like to build and deploy kind of at, see, bingo. Already failed, which is great. I didn't get too, this is why I like to do this, because I don't like to get way too far ahead of myself. So what is the problem here? The problem, okay, build failed. Docker is unreachable. Might help to start Docker. That's usually a good thing. Docker engine is starting. So Sam uses Docker and a specific AWS Docker image to build and compile the Lambda functions so that all the requirements in the outgoing zip file will be able to run successfully up in Lambda. And so obviously if you don't have Docker running, the build will immediately fail. And this looks much better. All right. So that's going to run. And I'm going to grab some coffee. And again, this is basically compiling into CloudFormation and then using CloudFormation to deploy all updates to the infrastructure, which is really cool. I could very easily go into the Lambda console and say to AWS, actually, let me show that. What I could do, here's my AWS account. I could go into, I think one of these is already Lambda. Getting too many windows open. That is my bucket. This is CloudWatch. All right, we're just going to open a new Lambda window. Okay, so here are my Lambda functions. These were created by CloudFormation by me doing a SAM deploy. If I come in here and look at this, so I could easily come in, create all my Lambda functions by coming in here, say new function, pasting in all my code, uploading a zip file. I could come in here and configure the environment of variables manually, which there aren't any yet because I haven't finished the deploy and so on. But if I were to then share this code with somebody else, they would have to go in and manually configure all this. So instead, I use CloudFormation. I keep the CloudFormation in source control, and then now I have infrastructure that I can deploy, which is really cool. Okay, so it's noting here that all these things have changed. Do you want to deploy this change set? I say yes, and so now it's going to go update this. And if I refresh the Lambda console, we should see the environment of variables populate once this runs. If it runs successfully, if I didn't screw anything else up, which is always kind of key. So, and if we go back over to CloudFormation, we would also see the exact same status messages of things getting updated. All right, successfully done. So if I refresh here, no environmental variables, refresh, now we have my environmental variable, thanks to SAM and CloudFormation. And just to be sure, if I go over to my code, you can see my code changes, where it's grabbing the environmental variable and so on. Neat. Okay. So I've been debating what function to work on next. I could work on transcribe. I could also stub out the vocabulary creation. So transcribe, as I mentioned a little bit earlier, can get better if you introduce custom vocabularies. Custom vocabulary is just something that this author did in the RSS feed solution that I'm borrowing from. But the way they did it is they built a little bit more robust solution around. They have two-step functions. The first one, you feed it a whole podcast RSS feed, and then for each episode in that feed, it calls the other one to go and process and transcribe it. So the first one, when it kicks off, it actually looks at the definition of the podcast. It looks at the description and grabs a bunch of text from there and grabs definition variables, and it creates the Amazon Transcribe custom vocabulary using that. We only care about one series of videos, at least for the purposes of this, which is the office hours videos that get archived in YouTube. So this whole state machine isn't really necessary, but there are things in here that we need to do, but we need to do them as like a one-time run thing. So the first one is creating a custom vocabulary. This isn't required, and I was going to skip over it, but I think actually I want to do it and create it because it's a really interesting thing that we have to go through in order to get this to happen. So, and a lot of other things like state machines and Lambda functions, we can use CloudFormation to just deploy this as a resource. Say, here's my custom vocabulary. The issue is there is no CloudFormation support for Amazon Transcribe yet. So if I come over to Amazon and do a search of all the services that CloudFormation has support for, Transcribe is not there. And this happens. I would expect over time, in the fullness of time, that we would have Transcribe support, but we don't have it right now. So what does that mean? Does that mean we can't do anything with Amazon Transcribe and CloudFormation? Not quite. The really cool thing about CloudFormation is that you can define your own resources. So here, these are resources built and supported by AWS, but CloudFormation, oh, sweet. Sorry, I love White Lotus. CloudFormation AWS Custom Resource is what it's called. And again, I have a bunch of these that I've created in the past, so I'm just going to kind of borrow from my previous work. So again, custom resources allow you to use Lambda functions to go and do something. And the way this works is that I don't actually know all the details, but CloudFormation will execute a Lambda during the different lifecycle stages of a resource. So it'll say, go create this resource, in which case you then program, like, I'm going to go and create the vocabulary and set all that stuff up. And then later there is a delete phase. So if I delete the CloudFormation template, it calls my Lambda function and says terminate, and then I have to go and clean up anything that I want to. I don't have to, but it's always good stewardship to go and delete that. And it expects responses from Lambda in a very specific way, and here it uses the specific module called CFN response in order to package up the response from your Lambda so that CloudFormation can understand it. And there's all kinds of details about how exactly to use all this, and it gives you example after example after example. I am going to, again, borrow from myself. So in this solution that I built in the past, I have a custom resource helper that does a lot of this. And so here's my function, and then I packaged with it the CFN response Python, which you can get from the website I was showing you earlier, but I'm just going to copy it here in case they may need improvements to it that I'm not quite expecting. So let me just duplicate one of my function folders, and this will be transcribe vocab. And let me create a new file. This is the Amazon CFN response Lambda file. And then if I go over to the Lambda function here that I wrote, I'll explain this, but let me just copy it over first. This is the correct, no, I want to go here. Okay, let me delete a bunch of this. So here, what I'm doing in this other function is I'm like executing queries and creating different definitions and doing things that you can't do via CloudFormation and like Athena and SES and a bunch of other stuff. You see here, I'm very consistent with my logging. So here, let me delete this stuff, and I am missing the closing action. So let me go back to definition, because I believe there should be an action for, oh, sorry, not an action. It is, okay, I need to, let me find this. Let me find their example. Okay. This is not what I'm looking for exactly. Sorry, bear with me. Okay, let me actually, I'm in the wrong definition. Okay, Where is your sample code? They have it in a zip file, of course. Okay, let's just stick to this for right now. So the event coming in is coming from CloudFormation, and there's a custom resource action. Here I want to say create vocabulary, and I'll show how this maps over into CloudFormation in a minute. And so here I'm saying CFN response, so that I've imported the CFN response from the same folder, send the event saying it was successful, create vocab. And then this is if something broke and isn't working correctly. What I'm missing is the event. There's those different lifecycle stages is what I was talking about. Those are not present here. And so what I'm wondering is, where is a good example of being able to show that? Here we go. Maybe I just need to look in the right folder. Ah, here it is, request types. Okay, so we get create, delete, and update. So how does this exactly come in? Okay, the request type is sent in the request type field and the vendor request object sent to CloudFormation. Sent by CloudFormation when the template developer creates, updates, and deletes a stack. Okay, so I believe request type set to create. So I think what we need to do here, the neighbor dog is barking, and so my dog is crying because she wants to go play with the neighbor dog. Evie, you're okay. I think it looks like this, and we'll find out because I'm logging the incoming event, so we'll find out pretty easily. If this equals create, then we go and create something. Else if you will see me make a ton of Python typos as I go to. So Python is not my first language. I'm trying to get better at it, which is why I'm doing it here. So bear with me as I make stupid syntax mistakes. My first language I learned was PHP. Then I moved to Java, then Node.js. I could be doing this all in Node, but I'm trying to learn Python. Okay. Okay, so here we want to create the vocab. Here we would delete the vocab. Okay. So again, what are we doing here? Let's take a step back. This we're creating because Amazon Transcribe does not have CloudFormation support. What we are doing is we are creating a CloudFormation custom resource that will, when it gets executed, when the stack gets created, updated, deleted, it will call this Lambda function instead of creating resources. It'll call this Lambda function, which the Lambda function will create the resources. So it's kind of a pain that you have to do this extra step, but at least there is this extra way of doing it so that CloudFormation doesn't get super logged behind services as they keep going. So we are here. We're using the Bado framework to. Let me make sure I have all the correct dependencies first. Requests, JSON, logging. Okay, I think we're good. So now I need to get to the transcribe documentation, which I think I had open from yesterday. Okay, I don't. Well, if I do, it's somewhere else. So transcribe, right. Okay. So I need to, let me establish my transcribe client. And then I'm looking for an API. Actually, you know what? I started this whole Lambda down here. So I borrowed this Lambda again from that blog post that I was following along. So on the left here is the function I just created, my custom resource. And then on the right is the Lambda from that first state machine that they're doing. And so here they're creating that vocabulary, which is quite a bit of work to create this. And I think they're just doing it. I think okay, so what they're doing is they're parsing the RSS feed and reformatting all the words so that they fit what Amazon Transcribe's looking for. So a lot of this I think we can kind of skip over. But this is what we want to really focus on, is this API call. So my transcribe clients, create vocabulary name. So we need a vocabulary name. I am going to set this as a environmental variable. Transcribe vocab name. So I'll have to set that in a second. And then phrases, I also want to be an environmental variable, and I'll show you exactly why. I'll do that in a second. Vocab terms. Okay, so let's first, so this is all I really need to do then in order to, if I get a request type of create, I can just go and create my custom vocabulary, which then I'll use later. The thing that I'm neglecting here is that creating vocabularies could be a long-running process, and so I'm just kind of assuming that when you create this stack, it'll finish creating the vocabulary by the time you actually start running the state machines. If that proves to be a terrible assumption, like if this takes an hour to create a vocabulary, then we'll have to come back and readdress this. But that's okay. Okay, and then, so we're creating the vocabulary. I'm assuming Transcribe service has a way to delete a vocabulary. Bingo. So if someone deletes this stack, we need to clean up their AWS environment. And so we're going to delete the vocabulary if the request type is delete. So if CloudFormation says, hey, custom resource, go delete, we can go clean this up. Okay. So now I'm actually going to delete this other. I'll leave that there right now. I'm still copying and pasting from it. But I'll close the window. So now we have a really, really simple custom resource that we can use in CloudFormation. So if I come back over to my template, what does this look like? And I can get rid of this to do here. So again, I just deleted it. Here is my other solution where I've done this before. So I can just copy and paste for myself. I clicked the wrong thing. Deployment. Here's the template. Okay. It's a long solution. It does quite a bit of cool stuff. I was really excited about it. Okay. So here is that function. Actually, it's not that one. Custom bucket name handler. Oh. Let me navigate this. Okay. Yes, here's the custom resource function. So it's just a normal Lambda function definition. So let's go ahead and start that. Oops, come on. I like to kind of put stuff that runs once at the bottom of the CloudFormation template. I don't know why. Transcribe, vocab, create is the resource name I'm giving it. Type is going to be, let me just copy and paste a lot of this up here. So this would be transcribe vocab And actually, just add a comment to kind of establish this a different section. Environment variable, great. Okay, but I actually have 2 more environment variables, don't I? If I go back to my app, I have transcribe vocab name. So we'll call this unofficial office hours vocab. Hopefully there's not like weird rules around what the vocabulary name can be. We'll find out. And then what's the other environment variable that I set? Vocab terms. Okay. So let's look at that real quick. What is vocab terms? So create vocabulary. What is it looking for? It's looking for a string. And this string, an array of string that contains an array of strings. Sorry, it's a string array of vocabulary entries. So I can't pass in an array as an environment variable. And what I want to actually do is I want to create an input to this CloudFormation template. At the top is a parameter, CloudFormation parameter, which we haven't done yet, which is these vocab terms. So what I'm going to do is I'm going to go up to the top and let's go back to my definition of serverless framework. Sorry, that's not it. Here we are. And we should be able to, actually both these are CloudFormation now. Okay, scratch that. I'm just going to go up over here. So the top of CloudFormation templates, you can add parameters. So I'm going to add a parameter. The name of this parameter, you just name a parameter, give it a type and description, and you can actually give it default values too. So I'm going to name this transcribe vocab terms. And then the type is going to be string. And the default value, I'm actually going to make this basically an array of string, a string with commas delimiting the different vocab terms. So let's just do something like this. So we're not going to get too crazy yet. And so on. We'll come back and keep adding to this to make it a little bit better, but right now I just kind of want to establish the parameter. So now I can pass this in if I just do reference that parameter, it should pull that in here. But the problem is my function here is going to treat this as just a big string, but I need to convert it over into an array. So if I just split it, that should work, right? Python string split is just going to make an array. Yeah, that's exactly right. Sorry, I'm pretty confident in Python, but I doubt myself all the time, and I get my syntax between Node and PHP and others just all crash in my head sometimes. So, okay, now this function is looking good. We've defined it in CloudFormation, but if I did nothing else, this function would never actually get called. And this is a custom resource, so we actually do want it to get called, and we want it to get called at the beginning of those different life cycles. So create and delete of the actual template. So the way we do that is we use, bear with me again, I need to search through all this crap. Okay, so this is the role. We do need to define, well, the role actually gets defined here. So good point. Okay, transcribe vocab. So I need to update this role. I just copied this definition from above. So it's not get transcription job. it would be it'd be create vocabulary and delete vocabulary. It should be both of these. And these are IAM permissions. Let me validate that this is actually the correct syntax. So usually the IAM action is just a camel case of the function that you're calling, the method you're calling in the API. Not always. But let's double check that. Create vocabulary. Okay, so they don't actually have it defined. Come on, give me all the different. And some services will actually define all the different IAM permissions. Not all of them do that. I really like it when they do. The nice thing is if you run this and it fails spectacularly, the warning will tell you exactly what permission you're missing. So you can always look at that. But I'm not seeing that here. So let's just run with these two. Create vocabulary and delete vocabulary. Okay, but that wasn't what I was doing. So I was trying to explain oh no. I was trying to get to the point where okay, so this is my custom resource helper. This is actually how you tell CloudFormation to use that function as a custom resource. So let me explain this. So it's not setup files. That's just what I'm copying from. I called it create vocab. So I'm creating a custom resource type that is going to use, it's going to call a custom resource action of create vocab on this function. So this is the function that's going to use. It's going to pass in custom resource action of create vocab, which should match here, custom resource action. I'm starting to believe that this is not right. I may need to put like resource properties in front of it, but we will find out if this fails. And so here we go. Now we have a custom resource action. So we've defined some default terms here. I'll expand upon this as we go. This will, when during the create phase of this particular resource, it was going to call this Lambda with this custom resource action and the request type of create. And then during delete, it'll do the same thing, but call delete. So if this template gets deleted, it'll clean itself up. Really handy. We just did a lot of code. I will be shocked if this all works, but let's find out. Let's build it and deploy it. And again, I'm using a custom resource here because we only need to do this once. So we're only going to create the vocabulary once when this whole stack gets deployed. Later, once we've created that vocabulary, we don't need to create it again. We can go in and modify it, but that's a whole different process. And again, I had to create a custom resource because there is no CloudFormation support for Transcribe. So this is building, uploading, waiting. I did give this parameter a default value. So we don't have to specify it. We could specify it here in the SAM deploy, but since I gave it a default value, it'll just use that default value. So now, if I deploy this, it is going to, during deployment, it's going to actually execute this Lambda function. And we'll have the CloudWatch logs to see what actually happened. But I didn't log the responses from the APIs, but I did log the incoming event. So we'll have some detail to go off of, and we'll see what happens. So the key thing here too, CloudFormation won't finish until your Lambda is done executing. So if you create a really long running Lambda function, you're going to hold up CloudFormation deployments until that thing is actually done. Here I'm just kicking off a long running process, so not a huge big deal. Okay, it deployed successfully, which means the Lambda ran successfully and returned a value successfully. I'm kind of shocked by this, but let's go in and verify everything. Again, I'm getting too many windows open. Okay, so here's the CloudFormation stack that Sam is deploying. If I go over to parameters, I should now have my parameter there. Great. If I go to resources, I should have, my create vocabulary is now a custom resource pointing to this Lambda function. And if I go to this Lambda function, it should be what I just created. And if I go to my environment variables, there, everything's getting pulled in correctly. The real test is going to be going over to Amazon Transcribe and looking at custom vocabularies. Holy moly. That's pretty cool. It worked. That's really cool. I'm genuinely shocked. That really shouldn't have worked. But cool, really cool. I was hoping to see the, oh, I can download it. That's right. Pop-up window blocked. And there it is. So cool. I actually know what I'm doing a little bit. Let's not get cocky. Okay, so now I have this custom vocabulary, and I can actually pass this into my other function to say use this when doing transcribe. So I pass that in as a parameter here. You know what? I'm actually going to make this a parameter up here as well, which I should have done the first time. Transcribe vocab name. And so now I can just say ref that parameter. And then what I can do is come up here to my transcribe start and add this. I forgot to. There we are. Add this as an environmental variable to transcribe start. So let me explain that. So let me grab, I'm really lazy sometimes. Okay, so this is my transcribe start function. It's working fine. It did the transcription of the video, but one of the parameters to this API is vocabulary name. I commented this out because we didn't have a custom vocabulary yet. Now we do. So what I can do is pass in my environmental variable, and when this function executes, it will use our custom vocabulary that was set up when the stack was deployed. Pretty darn cool. And so now let me just build this. The reason why I want to build this again is I'm curious what's going to happen, because I made a change to my custom resource Lambda. I'm wondering if it's going to re-execute that Lambda. And if it is, it might fail because the definition already exists in Transcribe. So I'm actually really curious. I should have, hold on. Before I do that, let me come over here and log the response. So what I'm worried about is, because I made updates to this, is it going to recall create on this custom resource? And if it does, it's going to fail. This will probably throw an exception. Things will get bad, and I may need to catch that. Let's find out. The custom resources are really, really, really cool. You can do all kinds of interesting things. Like, for instance, I've created a custom resource in the past to go and create like a random unique S3 name for a bucket. Then I can use that name all over the place. There is a ton that you can actually, I execute Athena function or Athena queries to go create tables and all sorts of other fun stuff you can do with these. Again, the big problem is if you create long-running processes, it just makes your deployment that much longer to deploy. But that's just kind of the trade-off. Okay, let's deploy this and let's see what happens. I'm pretty confident this will just be completely fine. It is updating that function, but I don't know if it's going to update the custom resource. It will fail spectacularly over here if it does fail, which is kind of nice. Gives you all kinds of others. Cool. Okay, this seemed to work. Awesome. Awesome, awesome, awesome. So now my Lambda function here that starts the transcription process has an environmental variable of vocab name. So cool. Okay, let's go back to this. So what did we just do? We did a lot, but not really a whole lot. So what we did was we gave the Amazon Transcribe process a custom vocabulary to use to improve its accuracy. Again, take a huge step back. What are we doing? We are looking at Jeff and I, we host Alexa office hours every Tuesday morning. When we're done with that, there's an archived YouTube video that gets created. We're going to figure out, and soon we'll have a trigger to pull down that YouTube video and transcribe it. So the office hours around Alexa development. So there's a lot of custom vocabulary in that world, and we want to be able to take advantage of that in our transcription process to just improve the accuracy of the transcription. So I'll fill out that vocabulary as we go over time. I think I just got the key things working there, totally fine. But that vocabulary gets created once when you deploy this whole entire infrastructure. I've skipped over the media convert and the whole trigger here. So media convert, again, when you download the YouTube videos, they're in a format that Transcribe can't immediately pick it up. And so there's another AWS service that will convert it over. I did that manually for our one test video, and it took me a lot of trial and error to understand how to set that up. I do have the config saved, so I know how to do this. I am not a media expert on all the different encodings and such, but I did save something that works. We will get to that eventually here soon. But I think the next step to work on is the comprehend piece, where now we have, and again, if we look at Amazon Transcribe, yesterday we ran a job that did finish, and the output of that is going to look exactly like this. I'm not exactly sure what the mms are. I think at the beginning of the video, there's beginning of all the office hours, we have a video that plays music to kind of like cue up office hours. Maybe that's what this is. I don't know. I don't remember Jeff or myself saying all the way through. But that's what Transcribe will spit out. So comprehend helps by making more sense of what's going on here. Okay, so, and again, I'm stealing this from this blog post where someone way smarter than me in these two services, comprehend and Transcribe, is using this to transcribe an RSS feed of a podcast. They created a bunch of these lambdas, which I'm stealing. So once transcribe is completed, the next step is they process it by paragraph, and they also generate a full text transcript. So these are two lambdas. Here the state machine forks and now runs in parallel and waits for both of these to finish. and then uploads those results into Elasticsearch, which is going to be the full text search database that we're going to use. These two functions are quite complex. And in here, they kind of give a description of it. Most complicated function in the application: extract transcription data from Transcribe and break it out into paragraphs. These paragraphs are broken down by speaker, punctuation, or length. The output of this function is a file that contains all the paragraphs in the transcription job, as well as the start time when the phrases were spoken in the audio. And that start time is really, really key, because again, what we're looking for, we're going to create an Alexa skill at the end of this where I can say, show me from office hours when we talked about APL. And it'll start playing the video of office hours at that point in time. So this start time is really, really, really key. And then we're going to load that into Elasticsearch, and then we're going to query that. So these two Lambda functions, do I have it here? No. Are defined here. These are heavy, heavy, heavy Lambda functions. And really it looks like what they're doing is they're just parsing the text based upon punctuations and links and when the speaker changes and things like that. And then they are creating the output of this is what we're going to load up into Elasticsearch. I don't want, so I've deployed this before. I ran this on this office hours video, just kind of like prove out this concept will even work. And it did work. And so what I'm going to do is I'm just going to basically steal this line for line, and there's not too much we need to actually change in it. It should just work because we're kind of following their whole process. So let's work on that. So let's duplicate this. So this is going to be comprehend paragraph is a new function here. So open up this and delete it and replace it with this. I am going to come and update some of the logging like I did at the beginning of today to make it more consistent with what I like to see for logging. It's just my personal preference. I'm sure their logging is probably better than mine, but that's just how I like to do it. So here, like they're using print statements. I'd rather not do that. The other thing too is I like to log. This is another personal preference of mine. So when you log the CloudWatch, things like this, where you have like text and then a JSON blob, you kind of lose out on some abilities in CloudWatch, in my opinion, that allow you to then search that JSON. So in CloudWatch, we can actually create JSON queries against our CloudWatch logs. And when you do this, there's probably still a way to do it, but I haven't figured it out. And so I like to just log just the event. Now, if I'm going to log text, so if I'm going to recreate this, what I would do is do something like this. And make these two separate log entries. So in CloudWatch, I could still have the raw JSON, but this is just my preference. I know that the first logging statement is going to be the incoming event. And similarly, the return statement will also be the same. Okay, so what are the return statement here is just a bucket and key. Huh, cool. So I should make this one big variable. I should do that. Interesting thing is that they already have, so they're already using retval. And what are they doing with this? They are dumping this into S3. So I'm going to change, I'm going to call this S3 val. That way I'm not colliding with myself. And again here, this is a good example of where I am going to do two separate logging statements. S3 value is that. Okay, where else are they using print? Actually, let's make these debug statements. Mapping, let's get rid of that print statement. You know, since they're using print, I bet they haven't imported logging, which should be important. Common lib I got rid of. So they created a common lib file where they pulled in some various things. One of them was this ID generation function. Cool. Okay. So where else are they using print? This might be a good place to use info. Okay, so no more print statements here. Now, the other thing is we want to make sure that the input to this Lambda function, this event, fits the format that our state machine is currently running in. And we got to look at other things like environment variables, make sure those are all set correctly, which we will also get to. We haven't even defined this function in CloudFormation yet. But let's go over to our state machine that ran. So the last, we're going to add it to the bottom of this. So the last output includes the transcription URL, and we're passing all this information in. So what I want to do is make sure that this event matches. So look here, they are expecting this whole information. So vocabulary info, mapping, and bucket. We don't have that. So where did they get that from? Let me just pull open their code and understand how their state machine is working. This should be, I bet if I do a search for paragraph. Cool. So their status, transcribe status, open this up over here. So where did they get these events is the question that I'm trying to answer. I'm not exactly seeing where they're getting that. Input path. Okay, but that's fine. We can recreate this. So this is basically the output that is going to go into this function. So the last function gets called as transcribe status. The output here, and again, I talked about this before. There is really cool ways that you can use state machine to map all these like inputs and outputs and keep status and state and a bunch of other really complicated things. I find that kind of difficult to wrap my brain around. And it's one of those things like it's like a regular expression to me. Like I can dive into it and spend a bunch of time understanding it. And then I can create these complex things, but then 5 minutes later it's gone. And so the way I like to handle this is just every function takes in inputs and passes the same inputs as outputs and maybe adds to it. And that's what we're doing here. So this is the output that this function is going to get as an input from state machine. So the transcription URL is definitely there, but it's much flatter than that. So the event transcription URL should match up with that. But it's also looking for vocabulary info mapping, mapping bucket and key. So really it's just looking for a bucket and key, which is actually located, I believe, well, actually, no, it's the vocabulary info. Okay, I get it. So where, I'm going to go back to their code because I may have deleted something that was important. Create transcribe vocabulary. Here it is, bucket and key. Interesting. Okay, so I definitely missed something. So when you create the vocabulary, put object, what are they actually putting here? They're actually putting the mapping. So pull the sign URL for the payload of the transcription job. I don't think this is the correct one. Might be this one. That starts the transcription job. Check transcribe. Nope. Okay. Let me do a search inside this repository. Yeah, see there. Okay. Why do they need the pull the sign URL for the payload of the transcription job? Why do they need the mapping? Oh, map the custom words back to the original. Interesting. So maybe during the they're creating a mapping here. I'm going to skip over that part for right now because I don't think this is necessary. So if we don't have mapping, because that's all this is getting, file content, yeah. Yeah. For key and mapping, file mapping, word. Okay. I may have to come back to this and re-add it. That's why I'm calling out the different areas. Okay. So what else? What other event parameters? Event. Okay, so transcribe URL. Okay. That looks actually pretty good. See, my assumption was it only needed this, which is the output of the transcription job. Okay, cool. So here we're returning just the bucket and the key. Where are these bucket and keys even? The bucket is from the environmental variable. The key is that. That's fine. But I want to actually add on more information. So I want to keep passing through all these different variables, right? So these are the new variables that we're adding, but we also are getting as input these variables, and I want to just keep passing them through so we have them for the next function. So bucket status. We don't necessarily need status. That's just kind of a temporal thing, but I definitely want to keep transcription URL, which is part of the incoming event. So again, I'm just going to keep passing this through. There's much better ways of doing this in state machine, but this to me is what makes sense. So the incoming event is also like all those parameters are going to get passed out. So the next Lambda function line can just inherit all these event attributes. So we don't lose any of this detail. Okay. So here we're running comprehend. So this function here, we haven't defined it yet in CloudFormation, but it is, let me delete these comments. It is going to be a rather, it needs lots of different permissions, I should say. So comprehend paragraph, all this is fine. It did need a bucket for the environment variable, right? Yes, bucket name. And we should be able to get the bucket name from here. I've used this elsewhere, right? Yeah. Where else do I use this? Oh, there it is. Yeah. Oops. Cool. So it needs a bucket name. What else does it need? Just bucket name and log level. Cool. Okay, but policies. Here we have quite a bit of policies that we need to do. So what are we doing with comprehend? Well, what are we doing with any of the services? So on client, we are putting an object. We are calling detect entities. And I think that's it. If we go over to, my dog is whining again. Here, again, they've created one Lambda policy for all the different Lambda roles. Not my preferred way of doing it, but we can at least see discrete list here. So here are, detect entities and detect key phrases. We're just going to copy these permissions over to our template. Come on, what's going on there? Okay, so we have comprehend, and then we also have S3 that we need to take advantage of. And again, they did this. This is not my favorite way of doing it, but let's just copy this for right now. We'll come back and I promise we'll fix this. I don't like giving anything this much access to basically do everything in S3 on my bucket. Like that seems crazy to me. But I also like put object also requires you to do a bunch of other things. So I don't want to necessarily find all those permissions just right now. Maybe I'll do that. I'll do that at some other point. And maybe I'll just actually create a to figure out exactly what is needed. I'm getting short on time, so I don't want to spend time on that, but I'll put a to-do in there for myself. Okay. I think this is all that this function needs to run. Now, what I need to also add it to my state machine. And this I may end up doing next time. So they do a split here and do these two things in parallel. And I do have, at least I did have documentation on I know pass is just one of the terms that will get me into the documentation. I know that there is a way to do parallel statements. So what we can do, we can find a parallel branch that has two branches on it. So let's just stub this out and at least get that going. So here next was end. We'll update that. But right now, comprehend parallel. And again, we can, because these are long running things, we can do these in parallel and make it just a little bit more efficient of use of time. Everything up to this point we haven't been able to do in parallel. We've had to do it linearly, but this we can actually do. So type here is parallel. And so this is an example of it. Branches. Come on. I'm only going to find one branch today because I haven't written the other Lambda function yet. And if we go over to theirs, there should be a very similar process here that they're doing. You can see here in their state machine, they are using like result path. This is a way of like routing information. I've been avoiding that because I just prefer to do what I have been doing, passing through all the variables through. But we'll start this branch at, so you do a start set. We'll do, what is this? Comprehend paragraph. Trying to make sure I don't misspell things. And then states. So the first state, or the only state really, is comprehend paragraph. It's fun writing JSON inside of a string inside of YAML, but you know, sorry. Task, and this is the end of that path, so we do say end equals true. And the resource is going to be something that we replace dynamically, and we'll call this comprehend paragraph, ARN. And then we just have to add that down here as our replacement variables. I totally misspelled that. Okay. And then I think we have to define what do we do after the after all the branches are done. So I think we define next would be the end end state with a capital E, right? Yeah, next, end. Okay. Cool. Next will be upload to Elasticsearch, but we don't have that done yet. So there we go. Now, we did a lot just now, so I want to make sure this actually builds and deploys. I won't actually run this yet. Or actually, I think I do need to run it just because it might take, it's going to take about a half hour to run, 15 minutes to a half hour to run. And then we can take a look at what happened with that next time. But I am running out of time. My dog's crying. Evie, come here. Come here. It's okay. She's a big baby. Okay, so it's uploading. It's deploying. What are the odds that there's a typo in my state machine syntax? Oh, even worse. Failed status. Get attribute references, undefined resources, comprehend paragraph. What did I name this? I forgot to rename it. That would be a good reason why that failed. So comprehend paragraph is the name of the resource that matches the code URI. When I copied the above one, I forgot to rename the resource name. That would definitely cause an issue. Let's try that again. This is how I code. I just run and sprint at it and then figure out where all the errors are and fix them and then just keep going. And then go back and refactor half of what I wrote because I realized my underlying assumptions were wrong, such as commenting out those mapping code lines. I have a feeling it's going to bite me in the butt, but that's okay. We will address that when we get there. That's how I program. It's why I'm not a real software engineer, and I'm a solutions architect. But I definitely have fun. So you can see as we add more Lambda functions, SAM has to compile each one of those, and it does that using a Docker image. So every time we add new Lambda function, the build process is going to take a little bit longer. And again, the build process, cool, that worked. So let's try deploying that. The build process, what it's doing is going in each folder. It's grabbing all the requirements from using pip and then zipping up the whole deployment package, which then gets uploaded to S3. So then the Lambda is able to execute based upon the zip. It all happens behind the scenes, which is really cool. Come on, work. Work, work, work. It's got the role. It's got the function. Those I'm not too worried about. The function actually executing, that's a different problem. The function actually deploying and getting created, looks like that worked. And now it's working on the state machine, and I failed the state machine. Neat. So what did I do wrong? Okay. Invalid error detected value. Unexpected character. Okay, so this is where CloudFormation doesn't necessarily give you a great view at what this problem was. So what I like to do is take this JSON that I'm writing into a string inside YAML and actually just paste it in kind of as a new state machine, as if I'm creating a new state machine. So then I can come in here and just kind of like branches, like I forgot a comma there. And then, okay, so that's the first problem. So in comprehend parallel, yep, forgot that. Okay, now it doesn't like starts at inside this branch. So what did I do wrong? Branches start at. That's always fun. My dog's chewing on something. Sounded like something she wasn't supposed to have. Start at. Okay, that is expected because it's just a replacement value. That's expected. That's expected. Okay. What are you chewing on? Dog? Stop that. Looks like she's chewing on my chair or something. Weird. All right. Come on. Building all those using Docker. All right. Because the last one failed, it did do a rollback, which is really useful. So the rollback, so it tried to deploy, it created a bunch of resources, it created the Lambda, it created the IAM role for the new Lambda. Ultimately, that whole change set failed to deploy, so it rolled back, which is another reason why I like to deploy often as I'm developing, is so that each incremental change set is small, and I'm not waiting on like this huge change set to deploy, figuring out there was one typo, like a missing comma, and then everything falls back. So I like to do these kind of micro builds. Okay, so we got to where we were before, those two assets, and failed. Missing comprehend parallel. That is a good catch. So what's telling me is that comprehend parallel is unreachable, and it is because I forgot to say go there instead of go end. I didn't know it actually checked for that. So now it's rolling back. That's kind of cool. It does that sort of checking. Like I expected to find that while debugging and realizing, hey, that never actually called that function. But did this? This didn't even detect that problem. Maybe it would have by the time it, if I resolved all these resource ARNs, it would realize that comprehend parallel is actually not called because I forgot to update that. Okay, I am going to cancel this. Leave. Again, I was just doing that to verify that my JSON inside of a string inside of YAML was being assembled correctly. My cold coffee now. I got this by working at AWS. It's one of the few things I've gotten. So I value it. Okay. Isn't this fun watching me do this? This is how I code. I fail, I retry, I succeed. Sometimes, like earlier today, I did a whole bunch of work and it actually worked the first time. That is not always the case, as can be seen here, but it's nice that I prove that I can every once in a while be successful in the first attempt. Okay, so when this is successful, I will kick off the state machine. We'll see what happens with it. And then next time, we'll add that other comprehend parallel path. And then hopefully it gets to the point where we can actually see what's happening with that. I'll also show, so this state machine, come on. Oh, wait, did it work? Okay, it worked. So now my state machine, if I look at the definition, should have more in it. Awesome. Okay, so cool. So I will kick this off. Let me kick it off right now. That's not, I need the input from the last time I ran this. So I'm opening up the previous one. I'm saying new execution with this input, and that should fail immediately. Neat. Cool. Cool. Syntax error. I introduced a syntax error. That's amazing. It was amazing. And I'm sure it was when I added the vocab name. Son of a gun. I'm a terrible developer. Okay, assuming that deploys correctly, I will kick this off. And then I will show, so this whole process, like this process took like 15, 20 minutes last time it ran successfully. And then we got down to here. What really stinks is to like wait 20 minutes every time you want to test something way down here, even though this is successful. So I'll also discuss like how can we run just these Lambda functions to test the entire thing without going through the step function. And we do that by looking at like the step inputs and outputs and so on, and manually triggering the Lambda function by going to the Lambda console. And then go back, once we get that working, then we go back and test the entire step function to make sure that that's working correctly. This is always fun when you are trying to wrap up a stream, but you don't want to end it on a complete and utter failure. So this should be a pretty small change set because we're only talking about really 1 comma that needed to be added. Line 88, and that's exactly where it was. Terrible. Okay, update complete. And complete. So now, new execution. Come on. It didn't fail immediately. That's good. Okay, so I think Monday, I worked out schedule. I think Monday, Wednesday, Friday, I'm going to be working on this from 9 a.m., I guess 9 a.m. my time, which I'm in Phoenix, so it's mountain time, but then we don't do daylight savings. So, but anyway, Monday, Wednesday, Friday at 9 a.m. my time, ending at 10:30, whenever. I'll continue this. So I will show the results on Monday. I'll show the results of what happened with this. If it actually succeeded all the way, that'd be really cool. That failed. I may like try and resolve that sort of thing. Forgot to import OS for the environmental variables. I'll clean that stuff up before Monday, and we can go from there. But thanks. This is a fun ride. Hopefully, I have no idea. But you're at least looking inside my brain on how I, a solutions architect at Amazon, build solutions with a bunch of different services and stitch them together. So with that, I'll end the stream and hope everyone has a great day. Thanks.